Mark your calendars for Friday, April 13th, 2029. A piece of rock the size of a cruise ship is going to come hurtling toward Earth. It will slice through the space surrounding our planet at an altitude of 32,000 kilometers. That is closer to the surface than the high orbit ring of our own geosynchronous satellites. Because it is coming in so incredibly close, roughly 2 billion people across Europe and Africa will be able to step outside, look up, and track it with their naked eyes. This flyby will be the rarest and most accessible astronomical spectacle in recorded human history. When astronomers first discovered this object in 2004, they named it 99942 Apophis, after the ancient Egyptian serpent god of chaos and darkness. Early calculations sparked global panic by suggesting a significant chance it could strike Earth. Even after the 2029 pass was cleared, scientists still feared a subsequent return in 2068 might result in a direct hit. Those fears were finally put to rest by precise ground-based radar tracking, which definitively ruled out any impact for at least the next 100 years. This sequence of images from the Goldstone radar shows exactly how we track distant near-Earth objects. By bouncing radio waves off the rock, astronomers collapsed the uncertainty in its orbital path from hundreds of kilometers down to a highly precise trajectory. The elimination of the impact threat has turned Apophis into an ideal, entirely safe scientific opportunity. Having an object of this mass come this close to Earth is exceptionally rare. Statistical models suggest an encounter like this happens only once every 7,500 years. As it flies by, Apophis will be subjected to intense tidal forces. Tidal forces occur when the gravitational pull on the near side of an object is significantly stronger than the pull on its far side, physically stretching it. Earth's immense gravitational field and magnetosphere will effectively grip the asteroid. This gravitational grip will warp the rock, altering the axis it spins on and likely triggering violent asteroid quakes that shake loose boulders and trigger surface landslides. Earth is essentially performing a live stress test on a massive space rock. The space immediately surrounding our world is briefly becoming a massive, free physics laboratory. If you're learning something new about our solar system, take a second to like and subscribe. Right now, space agencies across the globe are mobilizing an international fleet of robotic spacecraft to meet Apophis. The European Space Agency is launching the RAMSES mission. Its goal is to arrive at the asteroid before the April 2029 flyby to capture a baseline measurement of its shape and surface. Hot on its heels is NASA's OSIRIS-APEX mission, which will arrive shortly after the flyby to investigate exactly how Earth's gravity altered the terrain. OSIRIS-APEX performs a daring maneuver, dipping close to the asteroid and firing its thrusters to blast away the top layer of loose rock and dust. Analyzing that freshly exposed subsurface material allows scientists to understand the primordial composition of these ancient solar system time capsules. We are currently studying Apophis to figure out exactly how to deflect future asteroids that are on a collision course with Earth. For space agencies today, planetary defense equals applied planetary science. The better we understand how these rocks are put together, the better we can push them out of the way. Scientists must measure specific internal properties, like interior structure, density, and cohesion. Cohesion refers to how strongly the individual particles and rocks making up the asteroid stick together. If we hit an incoming threat too hard without knowing its cohesion, we might accidentally shatter it into a deadly shotgun blast of smaller rocks. The Apophis encounter is a live-fire drill. It provides the exact structural blueprints we require to build a viable, Earth-saving planetary defense system. Down here on the ground, the scale of this event is difficult to overstate. With an estimated 2 billion naked-eye viewers in 2029, this flyby will be watched by roughly 4 times as many people as those who saw Neil Armstrong walk on the moon. For observers in the Eastern Hemisphere, it will appear as a remarkably bright, fast-moving dot racing across the backdrop of the night sky. Throughout history, asteroids have acted as the universe's reset buttons for life on Earth. Today, our level of scientific preparedness means we can finally study them, we can map them, and fight back. Apophis represents a live final exam for a species learning how to save its own world.